All right, everybody. Today we're going to look at section 4.3, which deals with congruent triangles. So far, when we've talked about the word congruent, we've only talked about segments and angles, right? And segment and angles, two segments are congruent if they have the same length, and two angles are congruent if they have the same angle measure. So what do we mean when we are talking about congruent triangles, or more generally congruent polygons or congruent shapes that are beyond just single segments and single angles? That's what this section starts to talk about, is expanding this notion of congruence beyond just the simple figures that we've looked at so far. And so let's start to define that word congruence specifically for triangles and general figures. What you see is the first bullet point, right? Geometric figures are congruent if they are the same size and shape. So when we say same size, we're thinking about like lengths of the segments that make up those shapes. And when we think about shape, we're thinking about the angles that make up that shape, right? So angles here, same size. We're talking about, again, generally segment length if we're talking about polygons. Though sometimes we have some figures that have curves, like circles, and they don't have segments. But to start with polygons and triangles specifically, we're talking about segment lengths and angle measures. In order to talk about this more specifically, we have to introduce a couple terms: corresponding angles and corresponding sides. Now, we've seen this word corresponding before when we've talked about corresponding angles and the corresponding angles postulate, right? So if we have two, for instance, parallel lines, and we have two angles in the same position, then we have this notion of corresponding angles. But that's not quite what we mean when we're talking about congruent triangles or triangles that we're comparing. This word corresponding, again, means the same thing. It means figures in the same position in one shape that they're in the other shape. So matching up, if you will, the positions of a side on one triangle with a side on the second triangle, or matching up the position of an angle on one triangle with the angle on another triangle. And so we're pairing these things up in a way that their positions match. And so that's what we mean when we're talking about corresponding angles and corresponding sides in triangles. And I don't want you to get confused with the corresponding angles postulate, which specifically dealt with parallel lines. Okay, so now that we've dealt with these corresponding angles and sides terms, we can talk about congruent polygons. So polygons, remember, are just segments, shapes that are made up of multiple segments, many sides. So a triangle is the simplest polygon. And so two polygons are congruent if and only if both their corresponding sides and angles are congruent. So a triangle, or more generally a polygon, is congruent to another polygon if all of the sides that match up across the two polygons are the same length, and if all of the angles that match up across the two shapes are the same angle measure, okay? And so that makes the shapes themselves congruent. And so that's what we mean when we say same size and shape. We're talking about this matching up of sides and angles. So let's try to make that a little more concrete. So if you look at the diagram here where it talks about the properties of congruent polygons, let's focus on the triangles here. And you can see we've got triangle ABC and triangle DEF, and they're all marked up, right? And we can tell the corresponding sides and angles based on the names of the shape. I'm going to say it again. That's super important. We can tell the corresponding sides and angles based on the names of the shape. And when I say the names of the shape, I'm talking triangle ABC and triangle DEF. The order of the letters matters. For instance, angle A of triangle ABC corresponds to angle D of triangle DEF. Why? Because they're the first letter in each triangle name, okay? In this case, if I look at triangle A, if I look at angle A, I see it has one angle tick mark there, one angle mark. And if I look at D, it also has one angle mark. That is telling me that angle A and angle D are congruent. So in this case, these two angles, A and D, correspond to each other and they're congruent. So that's good. And I can check that for every other angle in the two shapes. Angle B corresponds with angle E, okay? And I can look at those two angles, B and E, and I see that they are both marked with 2 tick marks. And again, that means that they are congruent, right? Again, corresponding angles. I'm not, very specifically, I'm not looking at the shapes themselves without the congruence statement. I'm not doing that and like comparing, saying, oh, B has the same tick marks as E, that means they correspond. No, that's not true, okay? I'm looking at the congruence statement and I'm seeing that B and E correspond, and then I'm checking the picture. Are they the same? Yes, they are, okay? So that's a common mistake, right? People look at the pictures and then have a congruence statement that doesn't match that picture. And so we want to be careful about that. If we have a congruence statement, we need to check and see, do the corresponding parts of the figure match up? And then if we are going from the figure and we're trying to create a congruence statement, we need to make sure that we write it in the correct order, right? Okay, so I can see again for angle C, that's the 3rd letter in the triangle. Angle F is also the 3rd letter. I can see that they have the same 3 tick mark kind of thing, and so I can see they're congruent. Great. All of the corresponding angles in this particular example and diagram are congruent, and so I can see that, that for the angles, for the shape, everything matches up. And then I can do the same thing for the segments, right? And again, if I'm looking at the shape names and the congruence statement, so again, this here, triangle ABC is congruent to triangle DEF. That's the congruence statement, right? That's very important to pay attention to. That's the congruence statement. I can see, if I look at the names, like segment AB should correspond to segment DE because those are the first 2 letters in the respective congruence statements. And you can see, yes, they've marked those as congruent with 1 tick, with 1 tick mark. AB has 1 tick mark, DE has 1 tick mark, right? The second segment that I might notice is segment BC. It is the second 2 letters, and that corresponds with EF, and you can see again that corresponds there. Okay, and that's why they colored them the way they did in this picture, is so that you could see the things that match up are the same color. Okay, and then lastly, segment AC matches up with segment DF, and we can see all of those are congruent. And so what you're noticing here, I hope, is that in order to show that these 2 triangles are congruent, we had to show 6 facts, right? 3 angle pairs were congruent and 3 segment pairs were congruent, which is kind of a lot to show. You can imagine, like if you look beneath that, we've got 2 quadrilaterals, 2 4-sided shapes, and again, a congruence statement there. And that congruence statement has 4 letters, right? It says polygon PQRS is congruent to polygon WXYZ. Well, in order to show that those 2 polygons are congruent, those 2 quadrilaterals, we'd have to show 4 pairs of angles and 4 pairs of sides. So the bigger these shapes get, the more it's going to take for us to prove that those shapes are congruent. And so that's why we start with triangles, because they're the simplest polygons, right? So let's go about doing that and trying to show that we've got congruent triangles. So come down to this first example here. And it says given, right? And what we're given here is a congruence statement. That's what we call this, a congruence statement. Write that. It says identify all pairs of corresponding congruent parts. So this is an important skill. If we're going to prove that these 2 triangles are congruent, we need to identify which pairs of angles match up and which pairs of sides match up. So let's start with the angles, okay? So I might say angles. And I don't know, it says these are congruent, so what does that mean? It means that if these triangles are congruent, then their corresponding parts are congruent. So I'm first looking at, let's say, angle P, right? What does it match up with? Angle S. Why? Because it's the first letter in each triangle name, right? So angle P is congruent to angle S. And that's all I'm doing is I'm looking at the ordering, right? And then I might say, okay, the second letter is Q, and the second letter is T, so that tells me angle Q is congruent to angle T. And then I look at the last letter, of course, and I get that angle R is congruent to angle W. And that's my first set of figures, the angles. Okay? Then I can look at the sides. What sides correspond with each other? I'm going to do that on top here. First side is PQ. What does it match up with? It matches up with ST. Again, the first two letters. So that's the only thing I'm basing this on, right? Ordering of the letters in the congruence statement. PQ, segment PQ, right? Notice I'm using my segment notation, is congruent to segment ST, right? I don't want to forget the little lines on top, right? If I leave the lines off, I'm talking about lengths. It's not what I mean. Second segment, I've got QR, right? And that matches up with TW. So I would say segment QR is congruent to segment TW. And then the last one is a little bit harder to see. It's the first and last letters. You can't really identify it quite as easily, but like it's, you know, PR, I guess, and SW, right? It's kind of like wrapping around. So I might say segment PR is congruent to segment SW. And of course, we could reverse these letters as well, right? Those are the six figures that make up these triangles, and if we can, you know, find the corresponding ones, then that's how we break down that congruence statement into its component parts. Okay. All right. Let's look at example 2. We're given a congruence statement, and then it says find the value of x. Okay. So what that means for us is we have to figure out what goes with what, right? So looks like here, I'll mark the angles. We're talking about some angles. So we've got 49.3 here, and we've got whatever this angle is, the 2x minus 16, right? Okay, and so just look at the congruence statement, right? And what I'm noticing is that I know what angle BCD is, okay? BCD. So if I look at BCD, let's write this, right? The measure angle BCD. So I'm looking at that here. That's BCD. That's this angle. That's 90 degrees, right? But because of the congruence statement, angle BCD, I'm looking here, BC, I can kind of like 1, 2, 3, right? BCD corresponds with BCA, right? I'm looking at the names, the second letter, then the third letter, then the first letter. If I follow that in the other half of the congruence statement, the second letter B, the third letter C, and then the first letter A, this must mean, based on the congruence statement, that angle BCD is congruent to angle BCA. And again, I'm doing that based on the order of the letters in the congruence statement. But I already know that the measure of angle BCD is 90, right? So this tells me, the congruence tells me that the measure of BCD equals the measure of BCA. And so I know this is 90. And so I can see that as well just from the congruence statement, right? And that allows me to set up the equation as well, right? So you already knew how to do this problem one way using the linear pair, but now we have a second way. And we still get the same value for x. And so we can kind of double check ourselves and make sure that that's still correct, right? So that's how we would use this congruence statement to figure out the problem versus using a linear pair. Both of these are correct. Sometimes you're only going to be able to use the congruence statement. You won't have something as convenient as a linear pair, okay? So let's do the same thing, but again, this time with just the congruence statement on example 3. I'm looking now at angle DBC. So if we look at DBC, we're talking about this angle, okay? well, this angle isn't forming a linear pair with anything, so I can't use that way. I'm going to have to focus on the congruence statement. And if I look at DBC, that's the letters in order. So the corresponding angle is going to be ABC, right? ABC. Again, the same three letters in that order. So what is that? I'm going to say A, B, C. Oh, okay. That means these two are congruent. Great. Those are congruent. I'm trying to find DBC. Well, how am I going to do that? Well, I already know from before that this angle ACB, is already 90 degrees, right? I already know that. So since we know that ACB is 90 and that angle A is 49.3, well, I know from the triangle sum theorem, right, that the measure of angle A plus the measure of angle ACB plus the measure of angle ABC has to be 180. And I already know two of those angles. So I know the measure of angle A is 49.3. I know that the measure of angle ACB is 90 from before. And now I can find the measure of angle ABC. Now, why do I want to do that? Why do I want to find the measure of angle ABC? Well, because of this congruence statement. I know that since I'm looking for DBC, I know that angle DBC is congruent to angle ABC. Why? Because those are corresponding angles in the shapes. Why are they corresponding? Because that's what the congruence statement says. Those three letters in that order match up. Okay? And so if I know ABC, then I know DBC because they are congruent. 49.3 plus 90 is 139.3 plus the measure of angle ABC equals 180. Okay? Therefore, if I subtract 139.3 from both sides, I'm going to get the measure of angle ABC equals 40.7? 40.7, I believe, if I did that correct. And I think I did. 40.7 degrees. Okay, that means because these two angles are congruent, I can conclude, therefore, that the measure of DBC is also 40.7 degrees. Okay, and that's the power of these congruence statements, is it lets us know, if we know one figure's measure in one triangle, then we know the other figure's measure in the other triangle if those are corresponding figures. Okay? Again, if I could just emphasize, it's all based on the ordering of these letters. Okay? That's how I know which angles match up. It's not because I'm looking at it. I'm looking at the congruence statement and deciding on that. Okay? Let's do example 4. All right. Given YWX and YWZ are right angles. Okay, so you might as well mark that. YW bisects angle XYZ. Okay, well, what does that tell me? Well, if that's an angle bisector of the large angle, then these two are congruent. Okay, and W is the midpoint of XZ. So if I'm looking at XZ, W is the midpoint, well, that tells me that these two segments are congruent. Okay. Lastly, I'm told XY is congruent to YZ. So I'm going to mark that. I'm going to mark that with double ticks to be different. I don't want to mark it with single ticks because that would imply all those are congruent. But that's not true. Okay, so that's a correct marking. Prove XYW is congruent to ZYW. XYW is congruent to ZYW. Okay, well, if we're going to do that, we need to show 3 pairs of angles and 3 pairs of sides. So let's start with the angles. Do we know any pairs of angles? Well, we know, we'll write this as a proof. This is going to be a longer proof because we have to prove 6 things, right? But we'll start with the angles. Okay, so step 1, we know angle YWX and angle YWZ are right angles. That's given. Okay. Let's figure out what we can conclude from that. Well, I know that all right angles are congruent by the right angle congruence theorem. So this is angle YWX is congruent to angle YWZ. And that's the right angle congruence theorem. Okay. Secondly, I'm given YW bisects XYW. And that's given. But that tells me that angle XYW, sorry, XY, this is XYZ, YW bisects angle XYZ. That tells me that XYW is congruent to angle ZYW, and that's because of the word bisects, right? That's the definition of bisect. Okay, so that's 2 angles. So notice I wrote angles here. I want to keep track, right? So here's one. I found 1 angle, I found 2 angles. Okay? I know I need 3 angle pairs. So let's find the 3rd angle pair. Okay, well we've got angle X and angle Z. Okay? Angle X and angle Z. Why might those be congruent? I don't have any information about angle X and angle Z directly. Right? I'm not told anything. I've used my givens as far as the angles are concerned. I've got this midpoint information, but that's about segments. And then I've got this other XY congruent to YZ, but again, that's about segments. So why is angle X congruent to angle Z? The reason that angle X is congruent to angle Z is that corollary that we learned, corollary to triangle sum theorem, dealing with the fact that if we know that 2 angles in one triangle are congruent to 2 angles in another triangle, that the 3rd angles must be congruent because they all have to add up to 180. That was called the 3rd angle theorem. Okay, so that's a good one to know. That's our 3rd angle. Now we've shown that all 3 sets of angles are congruent. Now in order to save space, I'm going to erase this because now we need to show that the segments are congruent. But we're going to have this proof, again, is very long, right? This is very kind of annoying that I have to show 6 things just to prove that these 2 triangles are congruent. And you might be thinking, holy smokes, Mr. Miller, if you're going to give me this on a test, this better be the only thing on the test because this is going to take forever. And you're right, it's going to take forever. It's annoying. So we're going to have to learn better ways of doing things, which is what the next section's about. But for now, this is what we got to do. So 3 sets of angles, okay, check. Now we need to do 3 sets of corresponding sides. So let me erase this. If you need to pause the video to copy that down, you can. Well, this is the worst erasing ever. Okay, so we're on step 6 now, and we're going to focus on the side lengths. And the first thing I see, again, are the givens. I'm going to write step 6 here. It says W is the midpoint of segment XZ. And again, that's given. And notice here, I didn't write all the given-ins at the beginning. I could have, but if you want to write them when you're using them, that's also okay, right? Midway through the proof. All right, what does it mean for W to be a midpoint? Well, again, remember the definition of a midpoint is that it bisects a segment into two congruent segments, right? And I marked that in my picture, but now I can say that, right? I can say, oh, that means segment XW is congruent to segment ZW. Okay? XW is congruent to ZW. Why? That's the definition of a midpoint. Again, I'm using what I just said to justify what I'm now saying. Okay? Okay, that's realize we're working on sides now, right? So that's one pair of corresponding sides. That's one. Okay. I need 3. So step 8, what else was I given? Oh, this is nice. I'm given that xy is congruent to yz. That's given. Okay. And then lastly, I need the third pair of sides. Well, let's look. If I look at the congruent statement, right, I see xw and zw, great. I see xy and yz, okay, those are the first 2 letters and the first 2 letters. What I haven't shown is yw and yw. Oh, that's what's left. This last segment is YW and YW. Well, YW is definitely congruent to itself. What's the reason? Well, what's the reason that something is congruent to itself? That's the reflexive property. We haven't used that very often, but this is a case where we would use it. Reflexive property of congruence. Okay, that's when something is congruent to itself. So, great. YW is congruent to YW. I've shown that the third pair of sides are congruent. Excellent. I've shown all 6 corresponding pairs of sides and angles that are congruent. Now, having done that, I can say the congruent statement, triangle XYW is congruent to triangle ZYW. And that is the definition of congruent triangles. Or congruent polygons, if we want to think about it that way. Okay? Showing all 6 corresponding pairs is the definition when we're talking about those kinds of shapes. Okay? We're going to stop there. No homework tonight. We're going to pick up this when I come back tomorrow and I see you, and that'll be it for today. So hopefully that made sense. Review that, have those notes filled in, so that we can do the remaining examples and pass back your tests.